In today's video, we're looking at inequalities. Now, this is an interesting word. It kind of has something to do with this word, right? Remember what equal means. Have the same value. And so from this word equal, we get the word equation, right, which is a mathematical statement that two expressions are equal. Two expressions have the same value. So if we want to say that two expressions do not have the same value, a mathematical statement that two expressions do not have the same value. Okay, we need something that's an antonym of equation, a not equation. And in the English language, for words that start with a vowel, one way to say the reverse of that is to preface that word, equation, with in or un. Right? So if we're talking about mathematical statements that two expressions do not have the same value, they should be called inequations. But for reasons that I've not been able to figure out in my history of mathematics, inequality is the word that we use. Well, we could have said equal. We could have called these equalities, but that's not how it is. So equation means two statements do have the same value, and inequality is saying that they do not have the same value. Now it's a little more nuanced than that, as we'll see as we dive into the different inequalities. But let's start with some examples. So here's a situation. The variable a is 3 more than b. So you've got two variables on a number line. Just give ourselves a line here. All right. And I've got a. I'm saying a is 3 more than b. So I can translate that a is 3 more than this other thing. So I've got b, but a is not equal to b. A is 1, 2, 3 higher than b. Whatever b is, I add 3 to that, I get a. Right? My brother is a certain age. Sorry, I'm a certain age. My brother is 3 years older than me. Not that you guys know the difference, but I don't want to lie to you. So if you take however old I am this year, add 3 to that, you get how old he is this year, give or take a few months. Because you don't have the same birthday. So this is an equation here. A is 3 more than b. Now I don't know the value of a unless I know the value of b. But this relationship is fixed. And we learned when we were solving equations that we can perform the same new operation to both sides. I could shift both of these over. Let's not use 3 again. That was a bad choice here. Let's add 2 now. Right? If b grows by 2, right, if this side grows by 2, a is growing by 2 as well, it's still going to be 2 higher. Right? If this relationship is fixed here, I can do the same thing to both sides, it'll stay the same. Now, what's different between this statement and this statement do you see the difference there? I'm still comparing a and b, I can put A on here. A is more than B. So if this is A on the number line, B is somewhere over here. Let's make sure my A doesn't look like a 9. But I don't know how far it is between them. I know A is more than B, but I don't know how far I need to go. Is it 1 step or 17 steps or half of a unit? Right? Maybe A is over here. Maybe A is way over here. Maybe A is right here. Right? I just know that it's more than B. I can't set up this firm equation. I don't have a fixed distance separating the two. That's what makes this an inequality. All I can say is A is to the right of B. A is more than B. So this symbol here means is more than. Now there are all kinds of fun ways to remember which way this symbol goes. Does it go like that or this? Which one's more than, which one's less than? We can understand where this symbol comes from if we think about the equal sign. The equal sign is a relatively recent invention. People were doing math for thousands of years before they had this particular symbol. This symbol is used because we can see this distance here is the same distance as this distance here. That's what it's trying to signify, right? These two parallel lines, we're saying this side is equal to that side. As soon as I tilt those lines, this distance is no longer the same as this distance. Which distance is the longer distance? This one is. So this is the greater side compared to this one. And I think actually closing it to a point instead of still leaving some distance there just makes it easier to draw and easier to distinguish between a sloppy equal sign versus, right, we don't need to make it so long that it's clear that they're meant to be the same. If we're doing short equal signs, we might get kind of sloppy. So we would just connect it as a single sort of sideways V to show which side's the bigger side. So if I have the big side over here and the little side over here, then it's going to point the other way. And in English, we read from left to right. So here we're saying this one is on the little side compared to this. So this one is less than this one. So we call this the less than symbol. And then over here, reading left to right, this one's bigger than that one. So we call this the greater than symbol. But we don't want to get too caught up with those labels. We need to see this is a relationship here. When we call this the less than symbol, we're saying what's on the left is less than what's on the right. This is the greater than symbol because what's on the left is greater than what's on the right. But we're still saying the same thing if we use a different symbol. If B is the lesser number, I can put B over here. If A is the bigger number, I can put A over here. I'm saying the exact same thing using different words. A is greater than B. B is less than A. A exceeds B. A has a larger value than B. B has a lesser value than A. B is further to the left on the number line than A. It's the same relationship. What I don't know here is exactly how they compare to each other. Right? And that's how inequalities are different from equations. Now the way that we solve inequalities is going to be very similar to the way that we solve equations. Right? If this distance isn't fixed, it's just unknown. The fact that we at least know which side each variable is on, each expression is on, we'll still be able to use all of those properties of adding or multiplying that we use to solve equations. We'll get to that in the next video.